I couldn't resist the temptation to do a demonstration on resistors. Today I'm going to present a demonstration on resistors and how the length of resistors can affect the resistance in a circuit. To replicate my demonstration, you will need a 9-volt battery, a piece of A4 paper, a 2B pencil, a ruler, some wires, a white light emitting diode, also known as an LED, and tape. Credit goes to Junior Roberts for his video, How to Make a Resistor at Home, Homemade Resistor, published on YouTube on the 16th of May 2016, that inspired me to make my own resistor and adapt his idea to fit with the school curriculum. It would be ideal if all the children in a class could try this experiment for themselves, instead of just watching my presentation on the matter. For the first step, students will have to draw a rectangle on the piece of white paper. The rectangle should be about 60 mm by 5 mm. They will have to color in the rectangle with a 2B pencil and ensure that there are no white spaces and that you press relatively hard while coloring. Their measurements don't have to be precise, just more or less the prescribed measurements. The reason for this is that if they make their resistor too long, they might not be able to see the LED light up, as the resistance would be too much. Next, they will need 3 pieces of wire that are more or less the same length. It would be best for all the wires to be relatively short, because if the wires that act as a conductor are too long, the resistance in the circuit might be too high and the LED won't light up. Now, we will stick one of the wires to the positive pole on the battery and another wire to the negative pole. Make sure the wires make contact with the poles before applying adhesive tape. If you struggle with tearing off the tape, make use of a pair of scissors to simplify the process. The wire that is connected to the positive pole should also be connected to the LED. Twist the wire around the long leg of the LED, as it would be the positive leg, and fasten it with some tape once you are sure it is properly connected. Connect the remaining wire to the negative leg of the LED, the short leg. Attach the other end of the wire to your graphite resistor. Make sure all the wires make contact before you tape them. Use the wire that is connected to the negative pole and place it near the end of the resistor. Note down the brightness of the LED. Once you are done, move the wire closer to the middle so the resistor is now about 40 mm long. Note the brightness of the LED and then move the wire for the last time so the resistor is about 20 mm long. Note how bright the LED is and then disassemble the experiment. This demonstration is aimed at grade 7 to 9 learners, as all these grades will need to be comfortable with circuits, as they are an integral part of their technology curriculum. I've used the Impact Grade 7, 8 and 9 study guides to come to the conclusion that it would be beneficial for learners to understand circuits and resistors better. To make sure the learners benefited from this demonstration, they will need to make a conclusion and draw a simple circuit diagram. This will ensure that learners can accurately deduce how the length of a resistor will impact the resistance and that they know how to represent a circuit graphically. An example of both of these can be seen on the board behind me. Learners should come to the conclusion that the longer the resistor, the higher the resistance and the dimmer the LED. Or, alternatively, they could say that the smaller the resistor, the lower the resistance and the brighter the LED. They should also be able to draw a circuit diagram with the correct symbols. The focus is on making sure students can identify the correct symbols to use it to render their circuit graphically. This demonstration facilitates deep learning by allowing learners to create their own resistor and test exactly how the length of a resistor would influence the resistance of a circuit. They will be able to deduce from the brightness of the LED exactly how the length of a resistor might impact a circuit. According to Peter Ruel, in the article Lessons in Learning, published on the website The Harvard Gazette on the 4th of September 2019, students usually have better educational outcomes in classrooms where learners are allowed and encouraged to participate. This task is ideal as all learners can participate in building their own circuit. It also promotes student engagement by letting them build their own circuit and share in the joys of a successful endeavor with their fellow classmates. Students are using their hands and actually engaging with their work instead of just memorizing it and not being able to critically analyze it. This content is also accessible as the cost of entry is not high, and the learners who can't supply their own equipment are welcome to borrow mine to still experience doing this task on their own. Learners who have different needs can also be accommodated in various ways. Blind students will still be able to assemble a circuit on their own, but a facilitator may have to draw and color their rectangle and guide them at the end of the experiment, as they may not be able to accurately measure where 60, 40 and 20 millimeters might be. A magnetic buzzer could also be substituted for the LED. They should still be able to conclude that the longer the resistor, the more the resistance, as the buzzer will be softer the longer the resistor is. Learners that struggle with auditory processing can be given a printed list of instructions rather than relying on auditory instructions. This makes learning fun and enjoyable because children aren't stuck reading their book. They don't have to memorize abstract facts, but can see the effects with their own eyes and play with their circuit to better understand the concept. It is infinitely more fun than staring at words on a page. Some teachers might choose to play music in the background. Music without words, such as lo-fi or classical, as songs with complex lyrics might distract the kids, to create a joyous atmosphere in the classroom. This task promotes critical thinking, as they are expected to come to their own conclusion about the subject matter without input from a teacher. They will be able to better conceptualize their thoughts on resistor length and explain the concept more accurately than if they just learned it verbatim from their textbook. Even if they saw the effects, they are still encouraged to put their thoughts into words, and this might help them better explain the concept in exercises, tests, and exams. Learners who engage in hands-on science experiments are 75% more likely than their peers to demonstrate advanced critical thinking skills. This statistic can be found in the article 10 Benefits of Doing Hands-on Science for Students, published on the 2nd of August on the website Tokyo Academics and written by Trent Bombach. Thank you for listening to my demonstration and the positive effects such a demonstration can have. Hopefully next time you'll be equipped to light up your world all on your own.